Hello Techies and welcome back. I'm Sambhav here. This is the second part of matrix in R analytics. If you have not seen my previous videos on matrix, please don't forget to check them out. And also please subscribe my channel and hit the bell icon to get the latest updates on my upcoming videos. So in today's session, we are going to talk about matrix. And today's the main agenda would be accessing the matrix value, then how to use functions of the matrix. Then we'll also see a few basic matrix calculations and matrix with missing values, and we will have some assignments, some interesting questions to be solved, so that I will share with you at the end of the video, right? So let's get started with accessing the value of the matrix. Now when we talk about accessing the value of the matrix, so let's say for example this is a matrix. I hope you remember that this matrix we have actually created in the last class. In the last session we have created this particular matrix. Now what if I want to access few elements from this particular matrix? That is what we are going to learn in accessing the matrix value. The syntax is pretty easy, which is the matrix name, and then you have to use a square bracket. Please remember, you have to use a square bracket. Square bracket is used to access the elements of the matrix, and then you'll have to specify the row number and the column number. That means for whatever matrix you want to actually access, you will have to access those values using specifying the row or the column. Let's say for example, if I want to access the value 6, so this is on the second row and first column, so I'll have to specify 2 comma 1, right? Now basically there are three methods using which the matrix value can be accessed. One is the index method. Index method is nothing but the position. So as I gave you the example for accessing 6, I gave you second row and first column, which is 2 comma 1. So I'm specifying the index, that is nothing but the position of this particular value. Similarly, we can also access this value using the names. So as you know that the dim names, that is the row names and column names, so which I can specify as row 2 and column 1, that will also help me to access the value 6. How to assign the names of the rows and column, that we have discussed it in the previous video. So if you have not checked out my previous video, please don't forget to see the previous video, which is matrix part 1. And then using the logical reference. Logical reference is nothing but specifying true and false. So let's get started by accessing the value of the matrix, right? So using index, so we will solve this few questions by accessing the matrix elements by using rows, columns and all, and through all the methods, that is using their index, name and logical reference. So first of all, in order to do that, you will have to create a matrix, 3 by 5 matrix, numbers ranging from 1 to 15. So I've already created that. So this is a code for us to create the matrix. I've already kept the code ready, and I hope you remember that we have done this in the last video, right? So please don't forget to check that out. Now, accessing a single value. Let's say for example, I want to access 6. I want to access 6. So what will I do here? I will specify the name of the matrix, which is mat1, and then the square bracket. Now inside the square bracket, I will actually have to find the position of 6, and this position has to be found using the row and column, that is using the index method. So I will give it lies in the second row and the first column. So I will give 2 comma 1. So if I execute this, you see we have got the result 6 here, correct? Now similarly, we can also access a single row and a single column. Let me just copy this entire portion so that it will be easy for us to actually work out. So I'm just adding comments to each of these questions so that it will be easy for us. We'll not have to go back and forth to see the question. So accessing the single value, so we have done this. This is using your, this is using your index, the position. This is method 1. Now accessing using name. So what I can do, mat1, and then I can give a square bracket, and then I'll have to specify the position of 6, or you can by using the names. The second method is using names. So I will give here row 2 comma what, column 1. Now guys, please don't forget that you must specify the name in the same case. If you do not specify the name in the same case, I will not return the value. So you can see here R has returned the value 6. R has returned the value 6. We can also do this using logical references. So let's say for example mat 1 and then the square bracket, and then I'll have to specify true for the second row. So what I'll do is I will use combine function false. Now this has to be, logical values has to be specified in uppercase. So false true false means false for the first row, true for the second row, and false for the second row. And now I will have to specify true combine true for the first row, and then false comma false comma false comma false. So this is false for rest of the column. So if I execute this piece of code, object, oh, I have used C in uppercase, that is a problem. That is why it says that it is not able to interpret this portion C. So let's execute this and get the result. Now you see we have got the value 2. Similarly, the second question is accessing a single row. Let's say for example I want to access all of these rows, right? So what we will do is we will specify matrix name, same thing, and in the square bracket I will have to position this. So we can give the first row and how many columns? 1, 2, 3, 4, 5, all the 5 columns. So I can give 1:5, right? 1:5. This will give me the result. Second way of doing is mat1 square bracket 1 comma, and you don't specify anything after the comma. That means when you don't specify any value after the comma, it means all the elements. So if I execute this will also give me the same result, right? Similarly, you can also use the names. So you can give mat1 row 1, and then you can specify column 1, column 2, column 3, column 4, which will also give you the same result. Now let us try to access a single column. So let's say for example I want to access the first, or let's say the third column. I want to access the third column, that means 3, 8 and 13. So what I'll do is I will give the matrix name and then the square bracket. Now third column means all the rows, row 1, row 2, row 3. So I can give 1:3 comma third column. 3 is nothing but the third column. So if I execute this, I will get the result 3, 8 and 13. Or what you can do is you can use mat1 and don't specify before the comma. If you do not specify anything before the comma, that means for the row, that means it means all the rows. Now if you execute, you will get the value row 1, row 2, row 3. Now accessing random columns, let's say let me execute this once again. Let me clear this part, and so this is my matrix 1. Now accessing random columns, right? Accessing random columns. So how do we access random columns? So let's assume that I want to access first column and fifth column and all of the rows. So what will I do? mat1. Now all the rows, so I'm going to use comma, and I'm not going to specify anything before the comma. It means all the rows. But I have to access first column, so I will use combine function, and fifth column, because these two values need to be combined. So if you see, I will get the result for the value for the first column and the fifth column. Similarly, you can also access random rows. Let's say for example I want to access row 1 and 3. So mat1, and I will specify comma 1 comma 3, and just I'll specify comma here and I'll not specify any value because I want to access all the columns. So I've specified first and third rows and all the columns, accessing which are in the odd position. Now let's try solving this problem. It says that access the matrix column which are in the third position. So mat1, so I will have to access all the rows because we have to access the values from the odd position, odd columns. That means first column, third column and fifth column. So what we will do is we will have to write a logic for that. So we will give sequence 1 comma 5 comma 2. So this will actually generate a vector for odd numbers from 1 to 5, which is 1, 3 and 5. So now if I execute this, you see I'll get the value for 1, 3 and 5. So this is how you can easily access the matrix value. Now guys, you can use different functions, sum, min, max, etc. on these values. Let's say for example I want to find the sum. So I will use a sum function and put everything inside the bracket. See, I've used a sum function, and this code, this piece of code which is highlighted over here, it was mainly used to access the value. So if I want to find the sum of all of this, what will I do? I'll just use a sum and I'll execute it. It gives me the value 72. It will be more clear when we access a single row. See, accessing a single row. So when I executed this, it is accessing a single row value 1, 3, 5, 7. Let's say for example if I want to find the sum of it, so what will I do here is I will write sum, and then inside the bracket I'll specify this portion, right? I will specify this portion. Now if I execute this, actually R will calculate the sum of it. That means 1 plus 2, 3 plus 3, 6 plus 4 plus 5, 9, which is 15, right? So that is you can use any type of functions, right? Let's say for example accessing a single column. So here let's say for example single column was let's say this is the value 3, 8, 15. Assume that I want to find the average, so I can give mean of this value, mean of this. So this mat 1 comma 3, it means this 3, 8 and 15. So I can specify here and I can get the average of it. So it says average is 3 plus 8 plus 30 divided by 3 is nothing but your 8. That is the average. So you can use different types of functions like sum, min, max, etc. over this values. Now we will talk about matrix calculation. Matrix calculation, right? Okay. So when talking about matrix calculation, we can do addition, subtraction, multiplication, and so on and so forth. So let's create these two matrices. Let me create M1 and matrix of. Now the first matrix should be 10, 20, 30, 40. So what I will do is I will use a combine function 10, 20, 30, 40, right? You can use any logic to create this. Let's say for example if you want, you can use sequence function. So the start value would be 10, ending value would be 40, and by value will be 10, and this has to be in 2 by 2 rows. So if I execute this code and let's check the result. So we got this particular matrix. Similarly M2 matrix, and M2 is supposed to be 2, 3, 4, 5. So I will specify here 2 is to 5 and 2 rows and 2 columns, correct? So our M2 is ready. So let me clear this once again. So this is my M1 matrix and this is my M2 matrix. Now how do we perform addition? Addition means whenever we are trying to add these two matrices, actually the elements in their respective positions will be added. That means 10 will be, that is the first element, first row element will be added with the first row, first column element with the second matrix. So if I give here M1 plus M2, so you see it is added. So 10 plus 2, that means the first element, first row, first column element from matrix 1 is added with first row, first element with matrix 2, which is 12. Similarly 30 plus 4 is 34, 20 plus 3 is 23, and 40 plus 5 is 45. Similarly you can also do subtraction. So let's say M1 minus M2. Similarly this will be actually subtracted according to the position. 10 minus 2, that is what is specified here. So 10 minus 2 would be 8, 20 minus 3 would be 17, 30 minus 4 would be 26, 40 minus 5 would be a 35. So that is how we have got this particular result. You can also do multiplication. multiplication. Oh, sorry for this. Multiplication. So we can also do m1 into m2. Now you would notice the result. Now guys, see here there is a small twist. In multiplication, 10 into 2 is 20, 20 into 3 is 60, 30 into 4 is 120, and 40 into 5 is 200. That means the value are actually just multiplied based on their position. First element here, first element here. It is just multiplied. But this is not an actual multiplication. This is not an actual multiplication. The right, we will talk about that actual multiplication later. Similarly, you can also perform division. There is nothing much division. There's nothing much into it. Let's say m2 m1 by m2. So this will give you the result of it. Now there's something called as transpose of a matrix. Transpose of a matrix. So let me see matrix 1. So this is my matrix 1 which we have used earlier. Now what transpose does is it will exchange the value of row to column. That means the value, it is simply swapping it, say 1 2 3 4 5 6 7 8. So the value for the rows becomes column, and for the column values becomes the row value. Row value become the column value, and column value become the row value. So see 1 and 2, it is a column value, so now it has become a row value. Similarly 3 and 4 is again a second column which has actually become a second row. It is pretty easy to transpose a matrix. All you have to do is you have to use T. T is nothing but a function which is used to transpose the matrix. So initially we had 3 rows and 5 columns. Now you see it is 3 columns and 5 rows. The names also has been exchanged, which is not a proper naming convention. I mean, but it has just taken the name the way we have assigned earlier, right? So that is a transpose of the matrix. Now we also have to talk about the matrix actual multiplication. In the previous example, when we are trying to multiply two things, we have seen that it is just multiplying the value based on the position, which is not an actual actual matrix multiplication. Now in order to perform an actual matrix multiplication, you will have to use m1 percent star percent m2. So this indicates the matrix multiplication, not based on the position. So if I execute this, you see you will get a different result. Now how do we get this result? It is actually the first row here. 1 is actually multiplied by 7 plus 2 into 9 plus 3 into 11. So that will give you the first value. Similarly 1 into 8 plus 2 into, and so on and so forth. So that is how we get the matrix multiplication, which I was explained here. See, which is also called as a dot product, which is nothing but a dot product. So what we have done is 1 into 7 plus 2 into 9 plus 3 into 11, which will give you the value 11. That is called as a dot product, right? So that is how we get this value. That is how actual matrix multiplication is done. So I hope guys it is clear how to perform basic matrix calculations. Now there are few functions also available like row sum, call sums, row means, call means, which will actually calculate the value for you. So let's take mat itself. So now for example I want to find the sum of all the rows. Right, what is the sum of the first row, sum of second row, sum of third row? So what we can do is we can use row sums. Now please make sure there are two important things you have to remember. S must be uppercase and it is row sums, right? And let me give the matrix name, very easy, and it will give me the result. So the sum of first row, this is the first row, right? So 1 plus 2, 3, 3 plus 3, 6 plus 4, 10 plus 5 is 15. This is your 15. And this is your 6 plus 7, 13 plus 8 plus 9 plus 10 is 40. Similarly, 11 plus 12 plus 13 plus 14 plus 15 is your 65. Similarly, we also have, call sums, which will calculate the sum of the columns. That means sum of first column, second column, third column, and so on and so forth. right? See, we can easily find that. You can use row means as well, and you can specify the matrix name mat1, so it will give you the average. Similarly, col means, that is also available, right? These are pretty easy things. Now guys, we will also talk about having matrix with missing value. Let's try to create this particular matrix. So you see here the missing values are represented by NA. They are not available. So 1, 2, 3 is missing, 4, 5, 5 is missing here, 6. So how do we create such kind of matrix? So let me create another matrix called as mat3, and then I'll give matrix, and I will specify combine. So 1 comma 2 comma NA must be specified with uppercase, right? Then the second column was 4 comma NA, I think it was NA here, yeah, 4 comma 5 comma 6, right? And then we had 2 rows and 3 columns, 2 rows and 3 columns. So 2 comma 3. Let's create this mat1. So you see, oh sorry, it is matrix 3, I'm sorry. So you see our matrix is ready. Okay, why? Oh, it was supposed to be a different value. See, 4, I have to specify 4 here, NA, and 6. So that is how we should have got this particular value. Okay, but I have specified 1 comma 2. Okay, I have to specify by row is equal to true, because it is filling the matrix by column. That is why we are getting that result. So we will have to fill the matrix by row. So now we have got the value. Now guys, here also you can access the value of the matrix. Let's say for example, I want to access the first row. So what will I do is I will give mat3 and I will use a square bracket. So first row means I will give first row and all the columns. So I don't need to specify anything after the comma. So it will give me the value. Now how can I find the sum of it? So in the previous case we have seen that we just have to use sum function. But when you execute this, actually R will return the result as NA. The reason is because this one of the element is NA, and R cannot handle NA like this. So in order to handle NA, you will have to use an option NA dot RM is equal to true. NA dot RM is equal to true. Now you see it is finding the sum. Similarly, let's say for example, if you want to find the sum of the second row, so what you will do, sum, I'm sorry, so you will use here sum, and then let's say matrix 3, and we have square bracket to access the value. So second row, so I'll give 2 comma and all the columns. So I'll leave it blank after that, and then NA dot RM is equal to 2. So remove the NA and then calculate the sum. So this will give me the sum. So 6 plus 4 is 10. If you do not specify NA dot RM, actually it will give you the result NA all the time. So make sure that you specify NA dot RM option, right? Now guys, this is an assignment for you. I want you to do this particular assignment. So you have to create a matrix called as student, and there are 4 students, Ram, Shyam, Ramesh, Suresh, and they have physics, chemistry, maths, biology, 4 subjects. And this is the marks, and there are NA values. So once you have created the matrix, you will have to solve these 6 questions. Find the total marks obtained by all the students in chemistry and bio. Find the total marks obtained by Ram in all the subjects. So once, let's say, find the total marks obtained by Ram in all the subjects. So you'll have to solve all these questions, right? So that will be all for today, guys. Thank you so much for your time and patience. You have a wonderful day ahead, and please don't forget to subscribe my channel and hit the bell icon. Thank you so much.